Welcome to Adobe Math Lab. In today's lesson, we are exploring the distributive property of binary operations. Now, before we begin, let's think about what the word distribute means in everyday language. To distribute means to share or spread out something across a group. In mathematics, the distributive property tells us how one operation can be spread or distributed over another operation. Formally, we say that a binary operation star is distributive over another operation delta if applying star outside the parentheses gives the same result as applying it separately to each term inside, then combining the results with delta. Let's begin with a familiar example. Multiplication is distributing over addition and subtraction. Take, for example, 4 times 3 plus 2 bracketed. One way to calculate this is to work out what's inside the brackets first. That's 5. And 4 times 5 is 20. Another option is to apply the distributive rule and clear the brackets. 4 times 3 plus 4 times 2. 4 times 3 equals 12, and 4 times 2 equals 8. Adding them together also gives 20. So, both methods give the same answer, which means that multiplication is distributive over addition. It's the same for subtraction. If we wish to calculate 4 times 3 minus 2 bracketed, we can do the bracket first. 3 minus 2 equals 1, and 4 times 1 equals 4. We could apply the distributive rule and expand the brackets to get 4 times 3 minus 4 times 2. So that's 12 minus 8, which is 4. Again, the same answer, whichever method we use. So both sides of this equation match. This is why multiplication is also distributive over subtraction. Now let's look at a different binary operation. Suppose we define star by the rule A star B equals 2AB. If A equals 5, B equals 3, and C equals 4, calculate A star B plus C, A star B plus A star C. Then determine if the operation star is distributive over addition. In part A, we substitute 5, 3, and 4 for AB and C, respectively. Inside the brackets, 3 plus 4 equals 7. So this becomes 5 star 7, which means 2 times 5 times 7 equals 70. In part B, we substitute the same 5, 3, and 4 for A, B, and C, respectively. We should get 5 star 3 plus 5 star 4. For 5 star 3, we get 2 times 5 times 3. And for 5 star 4, we get 2 times 5 times 4, which is 30 plus 40 equals 70. The same answer when we worked the brackets first, so both sides are equal. Hence, the operation star is distributive over addition. Now let's test a different operation defined by A star B equals 3A minus B. We want to check if it is distributive over addition. We are told that A equals 2, B equals 1, and C equals 4. First, the left-hand side equals 2 star 1 plus 4, 1 plus 4 equals 5. So this becomes 2 star 5, which is 3 times 2 minus 5 equals 6, minus 5 equals 1. Now the right-hand side is 2 star 1 bracketed plus 2 star 4. Compute each separately. 2 star 1 equals 3 times 2 minus 1, and 2 star 4 equals 3 times 2 minus 4. This simplifies to 5 plus 2 equals 7. The left-hand side gave us 1, while the right-hand side gave us 7. Since they are not equal, this operation is not distributive over addition. Finally, let's look at a case where two binary operations are defined together. Suppose we define A star B equals A plus B, and A delta B equals AB. We want to check if star is distributive over delta. Take A equals 2, B equals 1, and C equals 4. Substitute the values to get 2 star, 1 delta 4. Since 1 delta 4 means 1 times 4 equals 4, this becomes 2 star 4. And recall that star means addition, so 2 star 4 equals 2 plus 4, which is 6. Now substitute the values in part B. That is 2 star 1 delta 2 star 4. 2 star 1 equals 2 plus 1, and 2 star 4 equals 2 plus 4. So we get 3 delta 6, which means 3 times 6 equals 18. On the left-hand side, we got 6. On the right-hand side, we got 18. Since they are not equal, star is not distributive over delta. This property is an important tool in algebra and abstract mathematics because it helps us understand how operations interact with one another. Thanks for watching. Don't forget to like, share, and subscribe for more lessons from Adobe Math Lab.